We're going to continue to work with methods for solving quadratic equations. In this case, we're going to be using the method of completing the square. Suppose, for example, that you have the following quadratic equation. 3x squared plus 6x minus 7 equals 0. If you remember, this is a quadratic equation. The highest exponent on the variable is 2, and this is written in standard form because we have one side equal. The first thing we're going to do in the method of completing the square is we're going to take the constant to the other side. And I will be writing the steps. Constant to the other side. The next step, we're going to get rid of this coefficient of the x squared by dividing every term by that coefficient. So we're going to have 3 over 3 x squared plus 6 over 3. The goal is to try to solve for x. Now we have x squared plus 2x equals. And I'm going to call this number a magic number. This magic number will give us the left-hand side as a perfect square. And to get this number, what we do is take the coefficient of the x term, multiply it by 1/2 coefficient of the x term, and square it. This is what I call the magic number. Okay. And so if we add a 1 to each side of the equation, and notice I'm going to be adding it here, and I'm going to be adding it on the other side of the equal sign, and I can do that because I have an equation, right? So we're adding this magic number to factor it. Notice that you will have two equal factors. The signs will be the same. In this case, they'll both be pluses, and we'll have x plus 1 times half. And so on the left, we're going to have x plus 1, the quantity squared. On the right, we have 7/3. We're able to achieve all the variables inside a perfect square, which is what we wanted, because now we can use the square root property, take the square root of each side and solve. So we can say the square root of the left-hand side, which would be x plus 1, equals plus or minus the square root of the right-hand side, which is equal to 10/3. And finally, equals minus 1 plus or minus the square root of 10/3. Rationalize, and so let's take one more step and plus or minus the square root of 10/3 if we multiply either inside or outside the radical by square root of 3 over the square root of 3, we will have minus 1 plus or minus the square root of 30 divided by the square root of 9, which is 3. And so we have found our solution. So we've used the method of completing the square by the x. Okay. Let's continue to use this method to review it, and now I'm going to put on one side the steps for this method, and you can follow a little bit more clearly what I'm doing. This is called an algorithm. It's like a recipe that we're going to be using in order to do this. Okay. So let's consider, in this case, we're going to have the quadratic equation 2x squared minus 6 is going to be to place the constant on the other side. That means I'm going to add a negative 5 to each side. So we'll have 2x squared minus 6x equals negative 5. I'm going to divide each term by the coefficient of the x squared. That's a 2 in this case. So we're going to take 2 divided by 2x squared minus 6 divided by 2x equals a minus 5 divided by 2. The next thing, and I'll go ahead and simplify that, x squared minus 3x equals a negative 5/2. The next step we're going to do is to multiply the coefficient of the x term. If you're working with equations, for example, in t halves, then it would be the coefficient of the t term. It's the coefficient of the linear term, the one that's raised to the first power. So we're going to take 1/2 times that coefficient magic number, so that when I add that magic number to each side, I end up with a perfect square. Well, if you notice inside here, what we're going to have is a negative 3/2. If I square that, I'm going to end up with 9/4. That's the magic number. So in this case, we'll have x squared minus 3x plus this magic number, which is the 9/4, which we're going to add to each side of the equation. Okay. Now, the left-hand side should be a perfect square. What perfect square is it? It's going to be x minus 3/2, the quantity squared. Now, how do I know that? I know from what I did before that I am going to end up with an expression which is a perfect square. I know the signs are going to be the same and they're both going to be negative, so I'm going to put the negative right here. And the way you should be thinking about this is to say, what number fourths? In this case, it's 3/2, so that when I square 3/2, I end up with 9/4. So the left-hand side is now a perfect square. Now, let's and so we're going to have minus 10/4 plus 9/4. The right-hand side equals a negative 1/4. The left-hand side is x minus 3/2, the quantity squared. So now we've been able to write this as a perfect square. So there's one more thing we need to do, and that is to take the square root of each side and continue to solve. Let's do that. So we'll take the square root of the left-hand side and of the right-hand side. Again, is to have all of the variables within a perfect square so that we can use the square root property. So when I take the square root of the left-hand side, and just to remind you again, it would be the square root of a perfect square, which in this case turns out to take plus or minus the square root of a negative 1/4. Okay. Notice that we've got a non-real number inside the radical, but that's okay. We can work with complex numbers, so that's no problem. Okay. Times the square root of 1/4. Minus 3/2 plus or equals, sorry about that. Let's scratch that plus out and put an equal sign here. X minus 3/2 equals plus or minus I. Add a plus 3/2 to each side, so we have x equals 3/2 plus or minus. Let's write this as an I over 2, or 1/2 times I. It's in the form of A plus BI once again. Okay? Method of completing the square